Hello everyone, I welcome you all to the lecture 16 of this course, Construction Methods and Equipment Management. In today's lecture, we are going to discuss about the piles and the pile driving equipment. So, in the last lecture, we have discussed about the trucks and how to balance the interdependent machines, say trucks and the loaders, how to balance them in terms of size and number, so that we can optimize the productivity. That is what we have discussed in the last lecture. Now, let us look into the outline of today's presentation. In today's presentation, we are going to discuss about the different types of piles. So, I will just give you a brief overview on what are all the different types of piles, because we can classify them based on the application, based upon the material type, based upon the method of fabrication, based upon the installation process. So, there are so many ways by which we can classify them. Okay. So, I will just give you an overview of how to classify and what are all the merits and demerits of different types of piles. Okay. So, then we will move on to what is the principle of the pile hammer. Okay. So, what is the principle of pile driving operation, and as you know that particularly the precast piles, they are subjected to more amount of driving stress. Okay. So, when you drive the pile into the ground, say we use a pile hammer. So, for the driving mechanism, it is subjected to a huge amount of driving stress. Okay. So, what are the methods to control the driving stress? Okay, that is what we are going to discuss, and also I will give you a brief overview on what are all the factors which governs the selection of a pile hammer. So, based upon the type of the pile or based upon the size of your pile. So, there are different factors which are governing the selection of the pile driving hammer. So, we are going to discuss about that in the upcoming slides. So, as everyone knows, the load of any structure is transferred to the ground through the foundation. So, this foundation can be a shallow foundation or deep foundation. Piles are deep foundation. Okay, they are examples for deep foundation. So, they are capable of transferring the load from the structure through a weak strata, and it can carry it till the depth where a hard bearing strata is available. Okay. So, the load of the structure is transmitted to the shallow or deep foundation, as I discussed just now. The deep foundation, that is a pile, is designed to transmit the structural load to underlying strata. And the load transfer can be either on the basis of end bearing or basis of friction, that we are going to discuss in the upcoming slides. So, basically your the pile foundation, you can see that it will act like a column. Pile is like a column driven into the soil. It transfers the load from the structure deep into the harder and stronger layer which can bear the load. So, when do we go for this pile foundation? Basically, when we have weak soils or soil with poor bearing capacity, we need to transfer the load till we reach a depth where you can find a hard load bearing strata. So, till that depth we need to transfer the load. So, for that we need a deep foundation like pile. So, the other requirement may be if the design load is very huge. Say for example, you need to design a foundation for a skyscraper or the multi-story building, okay, where the design load is very huge. In that case, people commonly go for the pile foundation. So, based on the application, so commonly there are different types of uses of piles. So, I am just going to discuss few common applications. So, one is your sheet pile and other one is your the end bearing pile and friction pile. First, let us see what are these sheet piles. The sheet piles, okay, so you might have seen this kind of the steel sheet piles. So, they are with interlocking joints, you can see that. So, they act like a rigid barrier for earth and water, okay, particularly during excavations or trenching. So, to protect the trench from the collapse, to prevent the trench from the collapse of soil, we go for this kind of sheet piles. For excavation or the soil conditions requiring temporary or permanent bracing to support the lateral load imposed by the soil, we go for this kind of sheet piles. So, it acts like a rigid barrier supporting the lateral load from the soil. It can also be used in water, like in coffer dams. It helps to act like a barrier for the water. It provides a dry working area or dry working environment. Okay. So, eliminating the need for dewatering. It can also be built in the water. So, you can use any type of material, like you can go for timber sheet piles or steel sheet piles or concrete sheet piles. So, it can be made out of different types of materials. So, commonly you can see the applications in retaining walls and coffer dams, as I discussed just now. So, this is again a picture of your the steel sheet pile. You can see the interlocking joints. So, this is mostly driven with the vibrating hammer. What is this vibrating hammer? All these things we will be discussing in the part 2 of this lecture. So, where we will be discussing about different types of pile hammer. So, this helps to support the lateral load from the soil, helps as a barrier to the earth. This is the picture of the timber sheet pile. Okay, as you know that timber is the oldest material. So, oldest building material, we have been using this material for so many centuries. Even now we use it wherever the timber is abundant. So, other type of applications are end bearing pile and the friction pile based on the mode of load transfer. So, particularly for the soil with poor bearing capacity, we go for this end bearing pile. So, the end bearing pile has to transfer the load through the weaker strata till it reaches the hard bearing strata, okay, which can carry the load, and the load is transferred through the end. That is why it is called as the end bearing pile. In the case of friction pile, okay, the load is transferred through the friction between the sides of the pile and the surrounding soil. So, that is what is friction pile. So, if the end bearing strata, okay, the hard bearing strata is reachable, it is within the reachable depth, then we can go for the end bearing pile. Otherwise, we have to go for the friction pile only. Okay. If the hard bearing strata is at a very greater depth, it is not reachable, then we can design a friction pile. Okay. But most of the piles you can see that they can transfer the load both through the friction mechanism as well as through the end bearing mechanism. Okay. So, that is also possible. So, this is what we discussed just now. The piles that reach the load bearing strata and transmit the load through the end are called the end bearing piles. Friction piles get the load bearing capacity from the friction between the pile sides and the earth. Okay, now we have discussed the few types of piles based on the application or the use. Now let us see the classification based on the material type. So, you can classify it into timber, concrete, steel and composite piles. So, timber pile, as I told you, this is the oldest material. So, I can say it is the oldest deep foundation known. So, it is very commonly used because easy to use, it is not expensive, okay, easy to cut it and splice it. There are so many merits with the timber piles. Okay. How do you basically use it? You just use a trunk of the trees, okay, cut it, trim it and strip off the bark. Okay. Why should we strip off the bark? When we use it as a friction pile, there is possibility of slip between the bark and the trunk. So, that is why we should strip off the bark and treat it with the preservatives. That is very important because these piles are more susceptible to rotting and insect attack, as everyone knows. So, particularly when the timber piles are subjected to fluctuating water table. So, you can see the issues of rotting and insect attack. This is because for the rotting mechanism, you need the presence of both water and the air. So, that is why timber piles which are permanently submerged in the water, they are not susceptible to rotting, they are not susceptible to insect attack. There are so many structures with the timber piles which are servicing for so many years without any damage, without any rotting or insect attack when they are submerged in the water. Okay. But the problem arises only when it is subjected to fluctuating water table, because you know that the presence of water and the air is necessary for these mechanisms. Okay. So, that is why in those cases where you know that it is going to be subjected to fluctuating water table, you should definitely go for the preservatives to prevent it from rotting. Okay. So, if timber piles remains permanently under water, they can have a long service life. That is what we discussed just now. And the untreated timber piles are subjected to insect attack and decay, and they will last only for few years. So, what type of treatment we can offer to the timber piles to protect it from the insect attack and rotting? So, basically in the olden days they used to soak the timber in the natural salt water. Okay. So, the natural salt water is the best preservative. Okay. But nowadays we go for modern methods like this the creosote with pressure treatment. Okay. So, that is found to be very effective for the treatment for insect attack and the rotting. Okay. So, let us look into the merits and demerits of this timber piles. Basically, the merit is it is inexpensive, easy to cut and splice, that is a major advantage. But the demerit is, obviously we know that lot of defects are there, natural defects are there in the timber like checks, splits, knots and shakes. So, we have to quantify the amount of defects in the timber before assessing its suitability for using it as a pile. We have to quantify, and whether the defects are within the permissible limit as given by the standards, we have to check before its use as a pile. And also there is a restriction on the maximum length, and the load carrying capability is limited. You know that when compared to concrete or the steel piles, its load carrying capacity is limited. So, that is why mostly we use it as a friction pile in sand, silt and clay. we don't use it as an end bearing pile, or we don't use it in very tough soil conditions like dense gravel, we don't use it. The timber pile is likely to get damaged easily when we drive it against a high resistance. So, when we drive in soils with high resistance, it is likely to easily get damaged. That is why we use it only as friction piles in sand, silt and clay. It cannot be driven against high resistance without damage, and hence not recommended in dense gravel or as end bearing piles to rock. So, the next is about the concrete piles. Obviously, when you compare it with a timber pile, its load bearing capacity is high. It has a high strength and has good resistance to decay. There is no issues of decay here. So, there are, based on the method of fabrication, you can either cast it at your project site, okay, or you can make it in the factory. So, accordingly you call it as cast in situ concrete piles or precast concrete piles. So, what is this cast in situ concrete piles? What are the methods of making cast in situ concrete piles? Here also, based on the process of installation, you can classify it further into displacement method and non-displacement method. See, when you do the installation process, say if your installation process is going to disturb the surrounding soil to a greater extent, say if it is going to displace the surrounding soil to the greater extent, then it is called as displacement method. So, if the disturbance to the surrounding soil is minimum, then it is called as non-displacement method. So, basically there are two types of methods. Okay. Displacement method means it will displace the surrounding soil to a relatively larger amount. So, say for example, doing the driving, say in the case of cast in place concrete piles, so you will be commonly driving your steel casing into the soil. You have to drive the steel casing with a hammer. So, what are the different types of hammer used? As I told you, in the next lecture we will be discussing in detail. As of now, what you need to know is we will be blowing a hammer on the top of the steel casing, so into the soil. When you do this driving operation, what happens is it will displace the surrounding soil to a greater extent. Say if it is going to be clay soil. So, due to the displacement, you can see there will be a huge buildup of pore water pressure in the clay surrounding the installation point. That will result in the heaving of the soil around the installed pile. So, this kind of the displacement may happen. So, that is why we call them as a displacement method. So, there are two options to make the cast in place concrete pile. One is your driven method, driving. Other one is your boring method. Driven means I am going to drive the casing. Here we are going to drive, because it is cast in place concrete pile, we will be driving the casing with a hammer. That is why it is called as the driven method. Other one is a boring method. So, very commonly we use this auger boring method, okay, to make the hole into the ground. So, the first one, the driving method, is a displacement method, because it is going to displace the surrounding soil to a greater extent. But the boring method is a non-displacement method, okay, non-displacement method. First, let us discuss in detail about the non-displacement method. So, the commonly adopted mechanism or the methodology is the auger boring. Okay, we are going to discuss about this in this lecture. This picture clearly shows you how the auger boring is done. First, you set up the rig, okay. Then you can see this is the auger bore. It has a spiral or the helical, the drilling bit at the bottom, which can be rotated by the motor, and it is usually accompanied by a casing. So, when you provide the casing, it helps to protect the soil also from the collapse, okay, and acts like a formwork to your concrete. Okay. So, this is the auger boring method. You can see this is the spiral or the helical blade arrangement. Okay. So, this one can rotate with the help of the motor. So, based upon this rotary method, you can easily make a hole into the ground. This is the rotary boring method. Okay. You make the hole into the ground and place the casing. So, the placement of the casing and the boring is done together. Casing is nothing but a steel pipe. It will act like a formwork. It will act like a formwork, so that to prevent the collapse of the hole, and also act like a formwork for your concrete placement. Then, with the help of the supporting equipment like crane, as I told you, for the pile driving mechanism, we need lots of supporting equipment like the crane to lift your casing, to lift your reinforcement cage, and to place the tremie pipe. For all these things, we need the supporting equipment. So, now what you do, once the boring is done, the next step is placement of the reinforcement inside the bore hole. You place the reinforcement inside the borehole. Now, what you do is, next step is the concrete placement. So, very commonly we go for this tremie pipe method of concrete placement. Using the tremie pipe, you place the concrete to the greater depth, and now you can extract your the casing, so that you can reuse the casing. So, this is what is the commonly adopted method, the boring method for making the cast in situ concrete pipe. So, let me summarize. First thing is, you are going to use the auger for boring the hole into the ground, okay, and you remove the soil also. While boring itself, you place the steel casing which will act like a formwork, okay. Then with the help of the crane, place the reinforcement, followed by the placement of the concrete using the tremie pipe method, okay. Then once the concrete is placed, you can remove the casing, so that you can reuse the casing for the next piling. So, let me summarize. First, you need to rotate the hollow shaft continuous auger into the soil. It is a the rotary method, as I told you. So, you have the rotating hollow shaft continuous auger. So, it has a spiral or the helical auger, as I showed you, which can easily bore the hole into the ground, and it can remove the soil out of the hole. So, the soil is removed and the reinforcing steel is placed, and the concrete is injected with the help of a tremie pipe. So, this method we can recommend basically for the clay soil. So, basically for the clay, we should not use displacement method, okay. The driving method cannot be used for the clayey terrain. This is because when you try to drive the formwork or the steel casing into the clay, as I told you earlier, it displaces the soil to the greater extent. There will be huge buildup of the pore water pressure in the clay when compared to other type of the soil, which results in heaving. So, that is why particularly for the clay, you should go for a non-displacement method, and auger boring is the best choice, okay. Now, let us see the video clipping on how the auger boring method is done. Okay. So, in this video you can see how the boring method is done first. So, with the help of this boring method, you can make a hole into the ground, and also you can extract the soil from the ground. Okay, you can see this casing which helps to remove the soil. Okay, you can see it clearly. Okay. So, followed by that, you can see how the reinforcement caging is placed with the help of the crane. Okay. So, after the reinforcement caging is placed, you can see how the concreting is done with the help of tremie pipe. Okay. So, this is how the bored cast in place concrete piles is done. Next is, we are going to discuss about the cast in place concrete piles using displacement method. So, first is, we are going to drive the steel casing into the ground. steel casing is nothing but a steel pipe. It can be either open at the bottom or it can be closed at the bottom. So, drive the steel casing into the ground. Okay, this is your casing, you can see that. Okay. Now, how do you drive it? With the help of a hammer. You blow the hammer. Since there are chances that the casing may get damaged, and you have to reuse the casing for the further piling. Okay. So, that is why commonly you can see that inside the casing they put this mandrel. Okay. This is the mandrel. So, that you can blow the hammer on the top of the mandrel, okay, to avoid the damage to the casing. So, now you blow the hammer on the top of the mandrel, okay, and the casing is driven into the ground. Once it is driven to the required depth, you remove the mandrel. Now, place your reinforcement, okay, followed by the tremie pipe concreting. So, mostly for the pile foundation, as it is for the greater depth, we prefer tremie pipe method. So, you do the tremie pipe concreting. So, after that, you can remove the casing if needed, or in some cases they leave the casing permanent, so that it can act like an additional reinforcement to your pile. Okay. So, if you leave the casing, it is called as cased pile, or if you remove the casing, it is called as uncased pile. Okay. So, basically when the casing is closed at bottom, so it means that you are going to leave it permanent. So, the open casing, the casing which is open at the bottom, we remove it and reuse it. So, this is a displacement method, because this driving mechanism will displace the surrounding soil. So, let me summarize what we discussed earlier on the displacement method. So, cast in place concrete piles are constructed by driving the steel shell into the ground. Shell is your casing, and the steel mandrel is attached to the pile driver, is placed inside the steel shell. So, why the mandrel is placed? So that you can reduce the damage to your casing when you blow the hammer on top of it. In some cases, steel shell is left in place. It can act like an additional reinforcement. So, they generally have closed end at the bottom. If you are going to leave it permanent, they will have the casing will have a closed end at the bottom. So, generally when we go for the closed end pipe, obviously there will be more soil displacement, okay, surrounding it. But if you go for open end pipe, there will not be much displacement of the surrounding soil. So, mostly it can be used as either friction pile or as end bearing pile. You can use it in both the ways. You can use it for loose and medium dense conditions, and not recommended for the clay. As I told you, you never go for displacement method for the clay, because it will result in huge buildup of pore water pressure in clay and heaving. So, another advantage of all these cast in situ piles is that you can do some length adjustment of the pile at that site. Even if you are not able to predict the length requirement, if you are not able to predict the exact hot bearing strata, okay, the location of the hot bearing strata, and if you are not able to predict the length requirement accurately, also we can make some adjustments at this site. But for the precast piles which are made in the factory, so such kind of adjustments are not possible at the site. You have to go for either cutting or splicing, and that is very difficult with the concrete piles. That is why when you go for precast piles, we have to accurately determine the length of the pile needed. So, that is why we need to do a thorough prior investigation. You have to carry out the pile testing program. So, you have to do some preliminary pile testing to know the exact length needed, and also to assess the load bearing capacity of the pile, and also you should carry out some geotechnical investigations to know the complete soil profile. So, you need to know where is the end bearing strata, and also you need to carry out all the tests. Say for example, you need to know the standard penetration test. Okay, all these tests will help you to know the soil behavior, which will help you in the pile design. That is why prior pile testing is very much important before you do the actual piling operation in your project site. So, in addition to this, there is also another methods where they use this bentonite slurry for the piling method. Okay, what they do is they use the bentonite slurry to act like a formwork to the soil. So, this will be more cost effective when compared to the steel formwork. Okay. So, where the soil has a poor bearing capacity, they use this bentonite slurry, so that it will help to stabilize the soil and prevent the collapse of the soil. The bentonite slurry also helps in flushing your borehole. Okay. So, the thing is you can have a thorough flushing of the borehole, so that there will not be any muck or the left out material at the bottom end, which may reduce the end bearing capacity of the pile. So, that is the advantage of going for bentonite slurry. Okay. So, this is also one of the commonly adopted methods for cast in situ concrete piles. So far we have discussed about the cast in situ concrete piles. So there are two ways. You can go for the displacement method, that is driving method, or you can go for the non-displacement, that is boring method, and we have discussed about the auger boring. So now we are going to discuss about the precast concrete piles. So they are going to be made in the factory in control condition. Since it is made in the factory, you will have a good quality control. You will have a good control over the quality of the concrete than at the construction project site, and you will be requiring less time only. The productivity will be high in the factory. This is because we can even go for accelerated methods of curing, like steam curing, to accelerate the strength gain process. So you need less time when compared to the real cast in situ process. And for complicated concreting procedures like underwater concreting, it is preferable to go for precast concrete piles rather than cast in situ, which is more complicated. But what will be the demerit? Demerit is these concrete piles are likely to be very huge, so it will be very heavy. Handling of the piles is very difficult. So particularly when you handle the concrete piles, they are likely to be subjected to more amount of handling stresses, and they are likely to be damaged. So that is why handling has to be done in a very careful manner, and you have to provide some additional reinforcement to take care of the handling stresses. That is very important. But for the cast in situ pile, we do not need additional reinforcement for the handling stresses. But for the precast pile, when you design it, we have to add some additional reinforcement for the handling stresses, and we cannot go for a very lengthy pile. You know that concrete is weak in tension and it is a very poor bending strength. Okay, so that is why there is a limitation on the length of the concrete pile also. So that is what is given in the slide also. It's heavy, brittle, little strength in bending, and require more care in handling. So handling stresses are more. Okay, and another important thing is it is very difficult to do cutting and splicing with a concrete pile. That is why we have to accurately predict the length needed. So properly do the soil investigation to locate the end bearing strata and decide the length of the pile, because there is difficulty in changing the lengths at the site. Okay. So there are different shapes available: square, cylindrical, octagonal. Okay. So different shapes of concrete piles are available. And another important thing to be noted is we can go for this pre-stressing method, okay, to improve its load bearing capacity and to improve its resistance to handling stresses, okay, and its improvement in resistance to the deflection. Okay, we can go for pre-stressing method. Okay, pre-stressed the precast piles are very common. So what is this basic concept of pre-stressing? Okay, I will just introduce to you what is the basic concept. Basically what we are trying to do is we are deliberately introducing some internal stresses in the concrete, so that before the external load application we are introducing some internal stresses, so that later the structure can counteract the external loads when it is subjected to the load application. Okay. So these internal stresses will counteract the external load. That is what is the basic concept of the pre-stressing. So what we are doing here is we are applying tension to the tendons. Okay, you can see you are applying tension to the tendons with the help of a stressing jack. You stretch it. Okay. So now do the casting process. Okay. Now the concreting is done. Okay. Till the concrete attains the minimum strength, desired strength, say 24 MPa. Okay. You are not supposed to release the stressing. Okay. So once the concrete attains its minimum strength, desired strength of say 24 MPa, you can cut the tendons and release the stress. So once you release the stress, what is happening? The tendons will try to come back to its original length. Okay. But the concrete which is already hardened, okay, will prevent that. Okay. So it will transfer some amount of stress into the concrete, that is called as pre-stress. Okay. So we are transferring stress into the concrete even before the load application. Okay. You can see how it is subjected to stressing. Okay. So what happens is when it is subjected to the actual load, okay, so this pre-stress developed will counteract the actual load. Okay. So that is why your load bearing capacity will increase, as well as these piles cannot undergo deflection easily. Okay, and the handling will be easier. It is not easily subjected to handling stresses. It can easily take the handling stresses. It is not susceptible to damage during handling. Okay. So, that is the main advantage of pre-stressed concrete pile. So, if you are going to apply the tension before the casting is done, it is called as pre-tensioning. Okay. If you are going to apply the stress after the concrete casting is done, it is called as post-tensioning. Both the ways you can improve the load bearing capacity of the piles. Okay. So, basically when you go for this pre-stressing method, okay, you can increase the length of the pile, because as I told you, concrete piles, say for example the precast concrete piles, the normal conventional reinforced concrete piles, if the length is, say, now commonly we do not go beyond 15 meters, but if you go for pre-stressing method, you can even go up to 30 meters, because it can easily resist the handling stresses. So, that is one advantage of pre-stressing. So, let me summarize what we discussed earlier in the previous slide. So, here what do we do in pre-stressing? Using the stressing jacks, each strand will be pre-tensioned prior to the concrete placement. That is why it is called as pre-tensioning. So, following the concrete placement, the piles are covered with the curing blankets and steam is introduced, okay, to accelerate the curing process. You continue the curing and the pre-stressing forces are not released until the concrete has achieved minimum compressive strength of 24 MPa. Till that time, you should not release the stresses, okay, it will be under the stressing jack only. Now, after the concrete attains the minimum strength of 24 MPa, now you release the stresses. So, as I told you, once the stresses are released, the tendons will try to come back to the original length, which will be prevented by the hardened concrete. So, this will result in development of pre-stress in the concrete, which is going to counteract the external load when the structure is subjected to external load application. So, it results in high load bearing capacity, and you can go for greater length, say up to 30 meter, and also it results in better corrosion resistance when compared to conventional concrete piles. So, with this, let us move on to the steel piles. Okay, under the concrete piles, we have discussed about cast in situ as well as precast concrete piles. So, now let us discuss about steel piles. The main advantage of steel piles is its load bearing capacity is significantly high, okay, when compared to concrete piles, okay, particularly its unit load bearing capacity, okay, it is going to be very high, okay, and it has a very good bending resistance. That is why you can go for very greater depth, even more than 30-35 meters, I can go for steel piles. So, very commonly used in the marine environment where you need greater depths. Okay. Another advantage is cutting and splicing is very easy with the steel piles. That is why if your end bearing strata is going to be highly variable, it is not easy to predict the length of the pile. In that case, it is preferable to go for steel piles, because cutting and splicing is easy with the steel piles when compared to the concrete piles. So, the most commonly adopted forms are H piles or the pipe piles. So, very commonly you can see the H piles and the pipe piles usage. And one thing to be noted is this H pile is very good in driving, even in hard soil conditions. You can easily drive this the H pile into the hot soil. So, in a marine environment, we always prefer this steel H pile, at least the tip should be the steel H pile, because it is very much needed for hard driving. But the demerit is its high cost and the corrosion related issues, you know that obviously for the steel pile. So, that is why commonly what they do is they increase the cross section of the steel, so that it can take into account the corrosion, the related damage, and also we can go for other methods of corrosion protection measures like corrosion resistant coatings or cathodic protection. There are different measures, we can also go for that. As I told you already, in places where the end bearing strata is highly variable, okay, you cannot predict the length of the pile needed correctly, then go for the steel piles, because it is easy to cut it and splice it. Okay. Another important thing, you should know that with this H pile, when you drive the H pile, the amount of displacement to the surrounding soil will also be less, okay, when compared to the pipe piles. Next is about the composite piles. So, nowadays people are very much interested to go for composite materials, so that we can take the benefits of both the materials in the same pile. So, it is made up of two or more different materials, okay, we are able to enjoy the benefits or advantages of both the materials in the same pile. So, the commonly used composite piles, I can give you some example, say timber and steel combination is also used. See, the lower section I can go for timber, because as you know that, say for example, you are going to select a pile which is going to be submerged in water. The portion which is going to be submerged in water, you can go for timber pile, because when it is completely submerged in water, timber is not susceptible to rotting or any decay. That is why for completely submerged portion I can go for timber, which is more economical, but for the top portion you can go for the shell pile or the steel pile. So, this way you can economize the cost. Another example I can say which is more commonly used is pre-stressed concrete pile with a steel H pile at the tip, at the bottom. Why do we go for the steel H pile as a tip? Because it is very good for hard driving conditions. As I told you, for sea, for marine conditions where you need hard driving, go for a steel H pile tip. It will be easy to drive. So, but on the top you can have the pre-stressed concrete pile, which is more economical, as well as its load bearing capacity and the corrosion resistance is high. So, these are the common combinations. There are many other combinations also of composite piles. Now, let us see what is the basic selection criteria for the pile. Okay. How will you select the pile? Obviously, it depends upon the type of the soil. Okay. So, that is why you need to do the proper geotechnical investigations to know the soil profile. So, whether it is going to be a clayey terrain, or it is going to be a sandy or silty or rocky, or it has and what is the complete profile, you need to know it. So, before you select a pile. So, the pile type depends upon the soil type and also the availability of material. So, whether the material which you are going to use for making the pile is available in that locality, that is also important. It is always preferable to use a material which is available in the local place, so that you can do the cost optimization. Length of the pile needed, that is very important. Okay. As I told you, there is a limitation in the timber pile length. There is a limitation with respect to the precast pile, pre-stressed precast piles and steel piles. Everything has its own range of length possible. Okay. So, depending upon your length needed, you have to go for the pile type selection. Construction schedule, your productivity. Sometimes we do not have much time to make cast in situ concrete pile. If you want to speed up your project, in that case you have to go for precast piles. And what type of structure it is to be supported by the pile. So, how much design load it has to take. So, what should be the load bearing capacity, because obviously it differs for a steel pile, pre-stressed concrete pile and timber pile. So, according to that you have to based upon the design load expected, you have to make the selection. So, obviously we have discussed all the merits and demerits, you have to look into that and make the selection. Finally, everything is going to be governed by the cost. So, that also has to be taken into account when you make the selection. So, I have just given you a brief overview about the pile types, because we are going to spend more time to learn about the pile driving equipment in this particular course. So, that is why I have limited the time spent for the types of piles. So, let us now see what are all the piling equipment needed. So, the pile hammers or the piling equipment. Okay. So, pile hammers are not only the piling equipment, we need lot of supporting equipment for the pile driving operation. Okay. So, like you need the cranes to hold the pile and the pile hammer and also to hold the lead, everything in the right position. For holding it and lifting it, we need lots of supporting equipments. Everyone knows we use this piling equipment particularly during the construction of the foundation or the basement, that is during the ground engineering phase. So, you can see this usage of pile driving equipment in many civil engineering works, particularly during the ground engineering phase. And this foundation equipment includes not only the pile hammer, but also it includes the equipment to lift and position the piles and guide the piles during the installation. So, a lot of equipments are involved. We will be discussing that in the next lecture, okay, in detail. First, let me introduce to you what is the basic principle of pile driving. Okay. So, it is just like how you drive a nail into a wall with a hammer. Okay. The same way you are going to drive a pile into the ground with a hammer. Okay. So, you are going to blow the hammer on the top of the pile. So, what is the blow energy? So, it is going to depend upon your weight of the hammer and the height of the fall of the hammer. So, that is what is going to give you your blow energy in kg meter. So, this is how the size of the hammer or the pile driver is commonly pile driver or pile hammer. It is commonly expressed in terms of blow energy it can deliver Obviously, it depends upon your weight of the hammer and it depends upon the height of the fall. Okay. So, one thing you know it already is the entire energy what you deliver, it is not going to be transmitted for the driving operation, because some will be lost in friction, some will be lost in the heat generator and some will be lost in the rebound of the hammer. So, only some portion of the energy may be transmitted. So, that is what is called as blow efficiency. Blow efficiency is nothing but it is a ratio of transmitted energy to the input energy. Okay. So, we always prefer to maximize this blow efficiency. So, that will help you to maximize your productivity. So, everyone knows particularly the precast piles are likely to be subjected to more amount of stress while driving it. Okay. They are subjected to more amount of handling stresses, as well as when you drive the pile into the ground, they are subjected to more amount of driving stresses. That is why all these stresses should be taken into account when you design your pile. Okay. So, highest stress occurs in the pile mainly during its driving than when compared to during its service life. So, mainly during the driving it is being subjected to more amount of the stress. So, how to control the driving stress? So, the commonly adopted method is we have to introduce some cushioning material between the pile and the pile hammer. Okay. So, that is the basic thing we can do it. Particularly for the concrete piles, as you know, concrete piles are weak in tension, okay, and they are more brittle. They are likely to be shattered very easily when you subject it to a very high impact. That is why we have to protect the concrete pile from the driving stress by using adequate cushioning material. So, commonly used cushion is wood, timber cushion. Okay. So, you have to choose a sufficient thickness depending upon the length of the pile needed. So, we should never go below 10 centimeter thickness, okay, and we should replace the cushion at regular intervals as it gets worn out. So, insert adequate cushioning material between the pile driver cap and the top of the pile. So, this is a common setup which you can see to control the driving stress. So, what you can see, this is your pile and this is your hammer. So, you have two cushions, one is your pile cushion, other one is your hammer cushion, and there is also a head-shaped helmet which helps you to distribute the load uniformly over the head of the pile, so that there is no stress concentration at a particular point on the pile head. So, we can distribute the stresses uniformly using this arrangement. So, the pile helmet is needed to distribute the blow from the hammer uniformly to the head of the pile to cushion and protect the pile head. So, this is what is a common arrangement we follow for the protection of your concrete piles. So, another important guideline which you should keep in mind to control the driving stress is the driving stress will be very high when the impact velocity is high. That depends upon your height of fall. So, as everyone knows, the blow energy is nothing but your product of W into H. W is your weight of hammer and H is your height of fall or the stroke. So, if you want to increase the blow energy of your pile, it is preferable to increase the weight of hammer, but do not increase the height of fall, because if you increase the height of fall, this will increase your impact velocity and your pile head is subjected to lot of stresses. Okay. This may result in damage of your pile if you increase your impact velocity. That is why it is preferable to go for heavier hammer and shorter stroke. So, that is what is discussed in this slide. So, the driving stresses are proportional to the ram impact velocity, and your impact velocity depends upon your height of fall, V equal to root of 2gh. H is your height of fall. So, that is why, and the studies have found that your blow efficiency, already we have discussed what is blow efficiency. Blow efficiency is nothing but the ratio of transmitted energy to input energy. So, this will be high if the height of fall is less. So, the blow efficiency is going to be maximum when the height of fall is less. So, we have to reduce the stress by using hammer with heavier ram and low impact velocity. So, heavy hammer with low velocity results in higher blow efficiency than light hammer with high velocity. It is sensible to use the heavy hammer with low drop. So, basically if you want to increase your blow energy, better go for heavier hammer, okay, but don't increase the height of wall. Particularly for the concrete piles which are weak in tension, they are easily likely to get shattered, okay, if you increase the height of wall. So, there is a restriction on the height of wall for the concrete pile. Okay. So, we have to follow that and to reduce the height of wall and increase the weight of hammer to get your desired blow energy. That is the right strategy, and that will also increase your blow efficiency. That is what is proved in earlier studies, that the transmitted energy is more if you reduce the height of wall and increase your weight of hammer. So, now let us see how to determine the safe load on the piles. Okay. As the piles are likely to be subjected to more amount of stress during driving, we need to determine what is a safe load allowable on the pile. That is very important. There are very many popular relationships or formulae which have been derived already in this context. We are just going to discuss one such formula called as engineering news formula. It is very popular, engineering news, to determine what is the safe load on the piles. And also you can find what is the driving energy needed for the pile. Both these things I can determine from this engineering news formula, and this is basically derived from the elementary pile driving formula, which is nothing but your hammer energy equal to the work of soil resistance. That means, what is the function of your pile hammer? It is going to offer you the required blow energy to drive the pile into the ground. Okay. So, when you drive the pile into the ground, the pile has to overcome the soil resistance and make the desired depth of penetration. That is the work done. Okay. So, hammer energy is nothing but W into H, and the resisting energy is nothing but R into S. What is R? R is the soil resistance in the pounds, and S is the penetration of the pile in the feet. So, basically you have to blow the hammer on the top of the pile. Okay. So, you offer the blow energy and get the work done. So, what is the work done? You have to overcome the soil resistance and do the desired penetration for the pile. Okay. So, that is what is the work done. So, hammer energy is equal to the work of soil resistance. That is nothing but the product of the soil resistance and the product of the penetration of the pile in the feet. So, from this elementary formula, driving formula, the engineering news formula have been derived, which is commonly accepted formula to determine the safe load on the pile. It is nothing but 2WH by S plus 1, and this is for single acting hammer. If it is going to be a double acting hammer where the mechanism is different, the formula has to be modified. Okay. So, the main objective is introduce to you that there are many relationships available to help you to find what is a safe load allowable on the pile. Okay. For different types of hammers, you can find different relationships available, okay, and you can make use of it. Okay. So, basically in this formula they have incorporated a factor of safety 6. That means 6 times the load will be supported by the pile. So, R is the safe load on the pile in pounds, W is the weight of the hammer, that is the falling mass in pounds, H is the height of free fall for the mass W in feet, and S is the average penetration per blow for the last few blows, say 5 to 10 blows in inches. So, this is the formula derived for single acting hammer. So, if you want to determine the safe load on the piles, or if you want to know the desired the driving energy needed, you can make use of this equation. So, now let us see what are all the basic factors which governs the pile hammer selection. Okay. So, obviously we have to select a pile hammer depending upon the type of your pile. Okay. So, what will be the size of your pile, weight of your pile, according to that you have to choose the weight of the hammer. So, the common the guideline is your weight of the hammer should be at least equal to the weight of your pile. Okay. That is a common guideline, ideal case. Okay. But if the concrete piles are going to be very heavier, okay, and if those equivalent weight hammers are not available in the market, then at least select a hammer whose weight is equal to 1/3 of the weight of the pile. Okay. So, basically your weight of the pile, your size of the pile, and the material type, all these things are going to affect your selection of your hammer. Material type, because the hammer which you select for your steel pile and the hammer which you select for your concrete pile will be different, because concrete piles are easily likely to get damaged. Okay. So, that is why we have to be very careful in selection of a hammer for the concrete pile. Okay. So, when you discuss about the different types of hammers, you will understand these factors better. I am just introducing this factors to you. So, in the next lecture, after we discuss in detail about all the types of pile hammers, we will again discuss how you are going to select the pile hammer for a particular soil type and for a particular pile type. So, so what are the guidelines we will be discussing again. This is just a brief overview before we move on to part 2. So, you know that pile hammer selection is going to depend upon the size of your pile, type of your pile, that is the material type, the weight of your pile, and how many piles you are going to drive, the productivity needed, the project time schedule. So, everything is going to govern. And the important thing is soil type, whether it is going to be a very hard terrain condition with a high frictional resistance or a loose soil with a less frictional resistance. All these things will decide your hammer selection, because accordingly you need your blowing energy requirement will vary. And as you know, for this piling process, we need a lot of supporting equipment like crane to hold the pile, to hold the hammer, everything in position, and to lift it. So, we need whether the available space and headroom is available for the equipment, we need to check. And based on the type of crane available, the crane should have the lifting capacity, sufficient lifting capacity to lift your pile, to lift your hammer, and even lift your lead, which will help you to hold everything in proper alignment. So, it should have sufficient capacity. Location of your project, whether you are going to do the driving operation on land or in water. Say if it is going to be in water, you may need to have some equipments with closed coverings. Noise restrictions. See, you know that when you drive the pile into the ground with a hammer, it is going to produce a lot of noise. So, if you are going to do the driving operation in a residential area or near a residential structure or near hospitals, so there will be restriction on noise. So, in that case, we have to select a method which will produce relatively less noise. We have to go for silent pile driving methods like vibratory methods. So, we will see what is that later. So, there are so many factors which governs the selection of your pile hammer. So, we have come to the end of this lecture. Let me now summarize what we have discussed so far earlier. So, we have discussed about different types of piles. So, classification based on its use, based upon the load transfer, based upon the material type, and based upon the process of fabrication. So, based upon the installation process, so from different perspectives we have classified the piles. So, based on load transfer, so the load transfer can be occurring either to the end, then we call it as end bearing pile, or it can be through the friction between the surface of the pile and the surrounding soil, then we call it as a friction piles. Then cast in place concrete piles, based upon the displacement, it is going to create to the surrounding soil. We can call it as a displacement method, or you can call it as a non-displacement method. There are two approaches by which you can go for cast in place concrete pile making. Either you can go for driving method with hammers, or you can go for boring method. So, we have discussed even about the auger boring, and we have discussed the principle of the pile hammer and how to determine the blow energy of the hammer, because that is going to define the size of your hammer, and how to determine the safe load on the piles, and how to control the pile driving stress. We have to insert adequate cushioning material between the pile and the hammer. Particularly for the concrete piles, it is very important to protect the pile head from the damage. And another important guideline you should always keep in mind is, it is preferable to go for heavier hammer with low velocity. So, we should go for a shorter stroke. So, that will result in higher blowing efficiency, and it will also protect your the concrete pile from damage due to impact. So, these are the important references which I have referred for this lecture. In the next lecture, as I mentioned earlier, we will be discussing about what are all the different types of the pile hammers available, their mechanism, and how to make the selection of the pile hammer according to the pile type and according to the soil type. So, how to make the selection, that is what we are going to discuss in the next lecture. Thank you.